So today we are going to talk about two things. The first thing we're going to talk about is Pythagorean theorem. The second thing we're going to talk about is special triangles. So the first half of today's class is going to be notes on Pythagorean theorem. So we've seen this before, and I know we touched on it yesterday, but our Pythagorean theorem is a squared plus b squared equals c squared. What's important to know is that c squared is always the hypotenuse. Okay, the hypotenuse is the longest side or the largest side of your right triangle. So it's really important as we're looking at our right triangle. The way I identify my hypotenuse is I draw an arrow across from my right angle, and that's going to be my hypotenuse every single time. Okay, so example. So here's our right triangle. And if at any time the video is going too fast, please raise your hand so that our substitute can pause it so that everyone can stay caught up. I'm trying to go slow, but just remind the sub if we need to push pause for a minute. So I have a right triangle of 4, 5, and x, and this will be our right angle here. And I have another right triangle of x, 8, and 12. So again, in our first one here, let's start by identifying where the hypotenuse is. Okay, our hypotenuse is always across from that right angle, so our hypotenuse is x. And then our other two legs are just the other two values. It doesn't matter the order we put them in. So we're going to use our a squared plus b squared equals c squared. And we're going to say that 5 squared plus 4 squared equals x squared. Okay, so what's 5 squared? It is 25. And 4 squared is 16. And x squared. So we now combine like terms, and we get 41 is equal to x squared. So the exact number for our hypotenuse is x equals the square root of 41. If I wanted the approximate, again, we would plug that into our calculator and see what we get. Okay, now let's take a look at our second triangle here. This one's a little bit different because our hypotenuse is our 12 centimeters. So that's our c squared. So my legs are x squared plus 8 squared equals 12 squared. So I'm going to go ahead and simplify that out. Equals 144. And we subtract the 64 from both sides to get x equals 80. Or x squared, excuse me, equals 80. Okay, then I take the square root, and we get, when simplified, 4 square root of 5. If you have a TI Inspire, it will automatically reduce it for you. In order to get the approximation, remember we push Control-Enter on our TI Inspire. Okay, so that's our basic Pythagorean theorem. Now we're going to try one that's a little bit more difficult. Okay, so we have x, x plus 1, and x plus 2. Our hypotenuse is across here, so that's our c squared. So a squared plus b squared equals c squared. So that's going to be my c squared. So my first term, my a is x, my b is x plus 1, so I'm going to write x plus 1 quantity squared equals, and it's equal to x plus 2. And again, that's quantity squared. Okay, what do we then do in order to expand this? What do we call it? We are going to FOIL. So I get x squared equals, and this is a perfect square, so it's the first term squared plus 2 times the first times the second plus the second term squared. That should sound familiar with Mr. Shalene last year, but if you don't remember, you can go ahead and, we'll use a pen for this, FOIL it out, x plus 1, x plus 1, x squared plus x plus 1. So we get x squared plus 2x plus 2 plus 1, excuse me. Okay, and then when I FOIL out the right-hand side here, I get x squared plus 4x plus 4. Okay, what then do you think we're going to want to do next? Think about it. How would we solve when we had quadratic, when we have something squared? Okay, we want to move everything to one side and set it equal to 0. So I get 2x squared. Well, first here we're combining like terms. So 2x squared plus 2x plus 1 equals x squared plus 4x plus 4. Okay, and let's go back and erase this stuff so you can see it. Okay, so now I have x squared minus 2x minus 3 equals 0. How did we come up with that? I subtracted the 2x right here. I subtracted 2x or x squared from both sides. I subtracted 4x, and I subtracted 4. Okay, so now from here we have a couple of options. Before, in Algebra 2, or in Scholars Algebra, we learned how to factor, we learned how to use our quadratic formula. So I'm going to actually factor. This one's pretty easy to factor. We know that they're going to be different signs. So I have x plus and x minus, and then what multiplies together to equal -3 but adds together to equal -2? We're going to get -3 and 1. And the reason why we do this is because we want to set each of these equal to 0. So x plus 1 equals 0, and x minus 3 equals 0. So x equals 3 and x equals -1. Okay, let's take a look at these two solutions for a second. Is it possible to have an x value of -1? Okay, it's not. We can never have a negative distance, so guess what? That one's out of the question. So our only answer is x has to be equal to 3. Okay? So now let's apply this a little bit. I want to find the area. Yes, we're going to find the area of this the triangle, or of the square. Excuse me. We're going to find the area of the square. So all I know is the diagonal, though, is equal to 10. So somehow I need to find s, and then I need to square it. So if we use Pythagorean theorem here, s squared plus s squared equals our 10 squared. So I get 2s squared equals 100. Divide both sides by 2, and s squared equals 50. What is the area equal to? The area here is actually equal to s squared. So the area of my square is simply equal to 50 and whatever our units are, units squared. That's the area of the square. Okay? So let's take a look now at if we want to test if something is a right triangle or not. So we're going to take a look at if a squared plus b squared is not equal to c squared, then it is not a right triangle. So we just need, all we do is we plug in our values, and we have to remember that c is the biggest number always. So if we're taking a look at 11, 15, and 19, 19 is our largest number. So 11 squared plus 15 squared equals 19 squared. Okay, and I go ahead and I simplify this. So when I plug this into my calculator, I get 346 equals 361. That is false. So guess what? This is not a right triangle. Okay? So let's try another one. 7, 16, and 16.8 and 18.2. Okay, again, our largest number, 18.2, is our hypotenuse. So 7 squared plus 16.8 squared equals 18.2 squared. So we're going to go ahead and we're going to plug this into our calculator. And we end up with 331.24 equals 331.24. Is that true? Absolutely. So this is, in fact, a right triangle. Okay, so that's where we're going to go ahead and stop our our first video before we start onto special triangles.